this class, you are going to learn about the phenomena of electrolysis. Dear friends, electrolysis is the process of decomposition of electrolyte by passing the electricity. Electrolysis is a process of decomposition of the electrolyte by passing electricity. That means if you pass electricity through the electrolyte, then it will undergo decomposition to form the constituent substances. Okay. So decomposition will take place only by passing electricity, otherwise the electrolyte will not undergo decomposition. Now dear friends, electrolytes are those substances which conduct electricity either in the aqueous solution or in the molten state. Okay. Electrolytes are the substances that allow the electricity to pass through them when they are taken in the aqueous solution or in the molten state. Dear friends, aqueous solution means the solution of electrolyte prepared by dissolving electrolyte in water. Okay, solution of electrolyte in water is called the aqueous solution, and molten state means the liquid state of the solid electrolyte that is obtained by melting the electrolyte. If you melt the solid electrolyte, it will get converted into liquid state, and this liquid state is called the molten state. So the electrolyte is the substance that conducts electricity either in aqueous solution or in the molten state. Now you may ask one question: why they allow the electricity to pass through them when taken in the aqueous solution or in the molten state? The answer is very simple. The aqueous solution or the molten state of electrolyte will be containing ions, and these ions are responsible for conducting the electricity. Okay, so in electrolytes, the conductance is mainly due to the movement of the ions. Okay, the electrolyte will be containing moving ions when taken in the aqueous solution or in the molten state. Okay, now examples of the electrolytes are the bases like sodium hydroxide, that is NaOH, potassium hydroxide, that is KOH, and acids like HCl, that is hydrochloric acid, HNO3, nitric acid, H2SO4, that is sulfuric acid, and salts like NaCl, that is sodium chloride, KNO3, potassium nitrate, K2SO4, that is potassium sulfate, NH4NO3, that is ammonium nitrate, MgCl2, that is a magnesium chloride. All these are the examples of the electrolytes. So electrolytes are mainly acids, bases, and salts. These are the electrolytes. Okay, so we have to take the electrolytes either in the aqueous solution or in the molten state and carry out the process of electrolysis. Now the next question is how to carry out the electrolysis. Okay, so electrolysis can be carried out by taking the aqueous solution or molten state of the electrolyte in the non-conducting container. Okay, so for carrying out the process of electrolysis, we have to take the aqueous solution or molten state of electrolyte in the container which is non-conducting. So container should be non-conducting. That means you should not be conducting electricity. Okay, so electrolyte should be taken in the aqueous solution or in the molten state in a non-conducting container, and this container is called the electrolytic cell. The container is called the electrolytic cell, and the electrolyte produces ions in aqueous solution or in molten state. I told you earlier, it will be containing the moving ions. Okay, so whenever the electrolyte is dissolved in water or when it is taken in the molten state, the electrolyte will produce ions by ionization of the electrolyte. Okay, now when the electrolyte is taken in the electrolytic cell, then we have to dip two metal rods or plates in the electrolyte. Okay, so two metal rods or plates are dipped in the electrolyte, and one of them is connected to positive terminal of the battery and the other is connected to the negative terminal of the battery. Okay, so we have to take the two metal rods or plates and dip both of them in the electrolyte. Okay, so among the two, one is connected to the positive terminal of the battery and the other is connected to the negative terminal of the battery. Okay, now the metal rod or plate that is connected to positive terminal of the battery is known as the anode. Okay, so the one metal rod or plate which is connected to the positive terminal of the battery is called the anode, and the other one which is connected to the negative terminal of the battery is called the cathode. So anode and cathode, these two are known as the electrodes. Okay, so before connecting to the terminals of the battery, they are only metal rods or plates. When they are connected to the terminals of the battery, then they become electrodes. So one is the anode. So anode is the positive electrode. That means it is connected to positive terminal of the battery, and cathode is the negative electrode. That means it is connected to the negative terminal of the battery. On passing the electricity, the ions of the electrolyte will get discharged at the oppositely charged electrodes. I told you that the electrolyte contains the moving ions, so these ions will be attracted towards the oppositely charged electrodes. Okay, the positive ions will be attracted towards the negative electrode, and negative ions will be attracted towards the positive electrode. Okay, so anode is the positive electrode that will be attracting negative ions present in the electrolyte. Okay, so negative ions will be attracted towards the anode. So those negative ions are called anions. Why they are called anions? Because they are attracted towards the anode. Okay, similarly the cathode is the negative electrode that will be attracting the positive ions in the electrolyte. The positive ions in the electrolyte will be attracted towards the cathode, so those positive ions are called the cations. So anions will be attracted towards anode and cations will be attracted towards cathode. Okay, on passing electricity, these ions will be attracted towards this anode and cathode, and they go to the anode and cathode and get discharged. That means they lose the charge. Okay, now you can look at this figure. Now this is the electrolytic cell. The container is the electrolytic cell, and the electrolyte is taken in this electrolytic cell. Okay, this is the electrolyte that is containing the positive ions and negative ions. So you can see here these are positive ions which are having a positive charge, and negative ions are having the negative charge. So these ions will be moving. Two rods are dipped. So one is the rod that is connected to negative terminal of the battery. The other one, this is connected to the positive terminal of the battery. This is the battery. This is positive terminal that is connected to this rod. This rod is called the anode. The metal rod that is connected to positive terminal is called the anode, and the metal rod that is connected to the negative terminal of the battery is called the cathode. So negative electrode is the cathode that will be attracting the cations. The positive ions will be moving towards the cathode, and negative ions will be moving towards the anode. Okay, so if you pass the DC current, these ions will be attracted towards the oppositely charged electrodes, and they go towards those oppositely charged electrodes and they get discharged. Okay, now we shall consider the general example of the electrolyte. So you can take the electrolyte AB. AB is the general electrolyte that we have taken, and this the electrolyte is taken in the electrolytic cell. The electrolyte ionizes to produce A plus ion and B minus ion. Okay, so when the electrolyte is taken in the aqueous solution or in the molten state, it will produce the A plus ions and B minus ions. You can look at this equation. AB will be producing A plus ion and B minus ion. So A plus ion is the positive ion, that is cation, and B minus ion is the negative ion, that is the anion. Okay. Now two metal rods are dipped in the electrolyte and connected to positive and negative terminals of the battery. On passing electricity, the ions of the electrolyte will be attracted towards oppositely charged electrodes. That is, B minus ions are attracted towards anode. Anode is the positive electrode that is connected to positive terminal of the battery. So this will be attracting the negative ions. So in this case, the B minus ions are the negative ions. So they will be attracted towards anode, and A plus ions are the cations. They will be attracted towards the cathode. Cathode is the negative electrode, it will be attracting positive ions. So A plus ions are the positive ions. So cations will be attracted towards cathode. Okay. So when they go to the respective electrodes, they lose the charge, they get discharged. So at the anode, what happens at the anode is, so anode is the positive electrode. So negative ions will be going towards the anode, and here B minus ion is the negative ion that loses electron. So it loses electron. So the process of losing of electron is called oxidation, and it is also called a de-electronation. De-electronation is another term for oxidation. So oxidation takes place at the anode. So B minus will lose the electron and form B. B is the neutral atom. Okay, so B minus ion is losing this negative charge and forming the neutral atom B. So B minus carries one negative charge. So it loses one electron and form the neutral atom B. So this reaction will be taking place at the anode. That is oxidation or de-electronation takes place at the anode. Now let us see what happens at the cathode. So at the cathode, this A plus ion is the positive ion that will be attracted towards cathode, and when it goes to cathode, it gains one electron because A plus is carrying one positive charge. So it will be gaining one electron. So the process of gaining of electron is called the reduction, or it is also known as electronation. Electronation is another term for reduction. So A plus ion will gain one electron. A plus carries one positive charge. So it gains one electron and forms the neutral atom A. Okay. Now this is the equation 1. The ionization of the electrolyte is equation 1. Then losing of electron by B minus ion is equation 2. Gaining of electron by A plus ion is equation 3. So if you add equations 1, 2 and 3, you will get this equation, overall equation AB giving A and B. AB gives A plus B. So AB is decomposing into the constituent atoms A and B. So this decomposition is taking place by passing the electricity. That is why we call this as the phenomena of electrolysis. So the phenomena of electrolysis is nothing but the process of decomposition of electrolyte by passing the electricity. So here you have seen that AB is decomposing into A and B when the electricity is passed through the AB. Okay. So the electrolyte decomposes on passing electricity to form A and B. Okay. Now we shall consider the particular example, that is electrolysis of the molten sodium chloride. So you know that sodium chloride exists in the solid state. So when it is melted by heating, then it will form the molten sodium chloride. And this molten sodium chloride contains sodium ions, that is Na plus ions, and chloride ion, that is Cl minus ion. So these ions are formed by dissociation of the sodium chloride. Okay. So for dissociation, there is no need of passing electricity. Okay. There is no need of passing electricity for dissociation of the electrolyte. Dissociation means the splitting up of the molecule into ions. Okay. These ions are already present in the sodium chloride. They get separated when you melt the sodium chloride. The forces of attraction between Na plus ions and chloride ions will decrease, and those ions will get separated by heating. So molten sodium chloride already contains these sodium ions and the chloride ions. Okay. So the decomposition will take place only by passing electricity, not by dissociation. Dissociation will produce ions. Electrolysis will produce the constituent substances. Now let us see what happens if we electrolyze the molten sodium chloride. Oh, quite okay. Now this sodium chloride is producing Na plus and Cl minus ions. Okay. Now when molten sodium chloride is electrolyzed, chloride ions will be attracted towards anode. Anode is the positive electrode, I told you earlier. So the chloride ion is the negative ion that will be attracted towards anode, and sodium ion is the positive ion. So the sodium ions are attracted towards the cathode. Cathode is a negative electrode. So when they go to respective electrodes, they lose the charge. So at the anode, Cl minus ion will lose an electron. So oxidation or de-electronation takes place at the anode. Cl minus is carrying one negative charge, it loses one electron to form chlorine atom. Now this chlorine atom will combine with another similar chlorine atom and form the chlorine molecule. So chlorine gas is liberated at the anode. Okay, so chlorine gas is nothing but the Cl2 which is liberated at the anode, or you can write this overall reaction in this way: 2Cl minus losing 2 electrons to form 2 chlorine atoms, and those 2 chlorine atoms will combine to form the chlorine molecule. So chlorine gas is liberated at the anode by electrolysis of this molten sodium chloride. Okay, now let us call this as equation 2 here. This is equation 1. Here the equation 1 is multiplied by 2. Okay, because here you have 2 chloride ions. So for balancing that, you have to multiply equation 1 by 2. Okay, so equation 1 is the ionization of the sodium chloride. Now let us see what happens at the cathode. So at the cathode, Na plus ion gains electron. So reduction takes place at the cathode. Reduction or electronation takes place at the cathode. Na plus carries one positive charge, so it gains one electron. So Na plus 1 electron gives Na. So call this equation as 3. So multiply this also by 2. Okay, because here you have 2 chloride ions. Okay, and here you have multiplied this by 2. So here you have 2 Na plus ion. So we have to make this also 2 Na plus. So if you add these equations 1, 2 and 3, okay, you will get this overall equation. Adding equations 1, 2 and 3, we have 2 NaCl giving rise to 2 Na plus Cl2. So you have seen that sodium chloride is the electrolyte that is decomposing into sodium and chlorine. So sodium is a discharge at the cathode and chlorine gas is liberated at the anode. So these are the products of the electrolysis of molten sodium chloride. Okay, so when molten sodium chloride is electrolyzed, sodium is discharged at the cathode and chlorine gas is liberated at the anode. Okay, so the products of the electrolysis are sodium and chlorine. Okay, the products of the electrolysis of molten sodium chloride are sodium and chlorine gas. Okay, so but if we electrolyze the aqueous sodium chloride, same products are not formed. Okay, so the products of electrolysis depends upon the nature of the electrolyte. So here if you take molten sodium chloride, you will get sodium at the cathode and chlorine gas at the anode, because molten sodium chloride contains only 2 ions, sodium ion and chloride ions. But if you electrolyze aqueous sodium chloride solution, then sodium is not discharged at the cathode. In that case, hydrogen gas is liberated at the cathode, chlorine gas is liberated at the anode, and along with these two products, sodium hydroxide is also formed. Okay, so the products of electrolysis of aqueous sodium chloride are different from the products of electrolysis of molten sodium chloride. Okay, I hope you have followed this phenomena of electrolysis. Okay, so thank you very much and wish you all the best.